So we have covered a lot so far, from the significance of the IP addresses to their classification and the logic behind them. Now it's time to delve even deeper into this fascinating subject. So let's get started and understand more about IP addressing. Thank you. Welcome back. So the topic that we are now going to discuss is about IP addressing. So to begin with, you can see a computer on the screen with an IP address 192.168.0.10. So friends, this is a sample class C IP address I have mentioned here. So let's understand what this IP address means. Forget about the numbers here. Just consider that each number is a block. So if I segregate these numbers, we get 4 blocks or 4 fields. So this is field 1, field 2, field 3, and finally the field 4. This is a 4 field address, and that's where we call this address as a IP version 4. So that's where the name came in the beginning. If I have to talk about the OSI model, the IP address is the logical address, and this works at network layer. So if I count the layers from the bottom, network layer is at number 3, physical the layer 1, data link the layer 2, and finally the network layer. So IP addressing works at network layer, and it is called as a logical addressing. And this address works at layer 3. There are two versions of IP addresses. The first one is IP version 4, and the second version is IP version 6. So this is a 32-bit address, whereas the IP version 6 is 128-bit address. So going back to the previous slide, some people call these fields as octet as well. So do not get confused here. Either you can call this as the first octet, second octet, third octet, and fourth octet, or you may call it as the first, second, third, or fourth field as well. No problem. So each field is made up of 8 bits, and as there are 4 fields or 4 octets, it becomes 8 4s are 32, which makes this address as 32-bit address. IP version 4 is a 32-bit address, and now I hope you understand why we call this address as 32-bit address. So 8 bits in each class into 4 fields, so 8 4s are 32. So that's where this address is a 32-bit address. Now, as we all know, computers only understand the binary language. So if it's a 8-bit address and I make all of these bits as 0, then this is how it is going to look like. And this is the binary number. If I convert that to decimal, it is going to give me 0.0.0.0, which is the decimal equivalent of this number. Now, other possibility that we can have with binary numbers is we can turn all of them as 1. So first option, turn off all the bits or make all the bits as 0, which gives us the decimal number as 0.0.0.0. And if I turn all of them into 1, then it's going to give me a decimal equivalent as 255.255.255.255. Now, if we look at a higher level, the lowest the IP address can go is the 0000, and the highest we can have is 255.255.255.255. It means, so here on this slide, I have tried capturing the binary conversion of these decimal numbers. So if I make all the bits as 0, it is going to give me a decimal equivalent as 0. And if I turn all of them as 1, it's going to be 255 in decimal. So simple words, we can say the range of IPv4 addresses is 0.0.0.0 to 255.255.255.255. How this is calculated is with the help of the exponents of 2. So first number is 2 to the power 0. So anything raised to 0 gives a value as 1. So if you make 10 to the power 0, the answer is going to be 1. You make 100 to the power 0, the answer is going to be 1. So anything raised to 0 is going to be 1. So if I translate or if I calculate these values, I'm going to get these numbers. So 2 to the power 0 is going to be 1. And same way, 2 to the power 7 is going to be 128. So friends, now if I want binary 1, so I'll only use 1 at the first place of 2 to the power 0, giving me 1. If I want 2, so 2 to the power 1 is 2. So I'll make this as 1, this as 0. Now the sum is going to be 2. If I want 3, I need 2 and 1, right? So 2 to the power 1 and 2 to the power 0. So both the numbers I need. And that's where if I turn the last 2 bits into 1, it's going to give me decimal equivalent of 3. So this is the way. If I turn all the zeros into ones, I'm going to get a number as 255. So friends, this is it, and this is very straightforward, no rocket science. If you understand this, means you understood the entire IP addressing concept. So if you are confused on this particular slide, please try and calculate the decimal numbers to binary or binary numbers to decimal numbers using the URL that I have showed you. So you can go to rapidtables.com. Here in the from field, you can put a binary. In the to field, you can put a decimal. If you turn all of them as 0, it's going to be 0. If I turn first bit as 1 and all the others as 0 and calculate, it's going to give me a value 128. And if you go back to our slide, we have turned this bit as 1, rest all 0, and that's where I'm going to see the value as 128. If I want to get a number 129, so I'll have to change the last bit into 1, convert, and it is going to be 129. Now if you go back here, 128 and 1, adding these two numbers, I'm going to get a number as 129. This is how, if you keep on adding ones to the numbers and keep moving to the left, the last number would be a number which will have all as ones, and that is where it makes it 255. So let's go back again and put 8 times 1, and the value that I'm going to derive is going to be 255. That's how we can conclude that the IPv4 address starts at 0.0.0.0 and ends at 255.255.255.255.